Okay. So in machine learning, we are here Canon classification with train and split. Okay. So I would like to describe grid search CV. So before that, I would like to describe one thing algorithms. What algorithm internally used by the Canon. So coming to that points. In previous session, I have described here what is K-Nevers algorithms in what is K-Nevers algorithms. But once you let's suppose let's suppose you want to use K-Nevers algorithms here. So we can see here from scalar neighbors import K-Neighbors classifier. K-Neighbors classifier. So this KNN is applicable for, as we know that what is the majorly machine how many kinds of machine learning is one is. So if you are talking about the type of machine learning, so first one is supervised ML, then unsupervised ML, supervised ML, and unsupervised ML. Supervised ML or unsupervised ML. Right. In supervised ML, we have a two problem. One is regression, another one is classification. One is classification and regression. And unsupervised learning, the unsupervised learning is called clustering. There is another one also. Okay, another one machine learning is also there, but in industry there is nothing is no one is using. This is called reinforcement learning. Have you heard anyone reinforcement learning? Later I will describe, but this is also a reinforcement learning features engineering. So reinforcement learning now reinforcement learning in industry, it learns from environment. It learns from their environment, your computer environments. So later we will describe, but for your interview point of views or for your like you're talking about like 100 companies working on data science. Okay, so only 1% company maybe they are using reinforcement. Got it? So we can see here this KNN algorithms is applicable for which one? Applicable for classification, regression, regression. So let's talk about today we'll do discussion internally this KNN classifier or which kind of algorithms they use to compute their their which one name their distance their distance. As we know that minimally what we do like for we have a Euclidean distance, we have a Manhattan distance. Euclidean distance, that means p equals to 2. Manhattan distance, that means p is equals to 1. P is equals to 1. This is the distance. But I want to calculate this distance. How can we do that? Through that algorithms, how can we do that? So internally they use three algorithms. Which one? Internally, they use three algorithms. First, three algorithm, brute algorithm. First, brute, then KD tree, then KD tree, then KD tree, and then bold KD tree, and then bold tree. So today we'll discuss which one is the better and which one is the better. Today we'll discuss internally this algorithms is using which one is better. This data structure is, you can say, data structure algorithm using which one is better. Then we'll do discussion. Let's suppose earlier we have a 2 points. Okay. As we know that this is a circle. Near this circle, what two object is there? Let's suppose one is triangle and another one is a square, a triangle or a square. So earlier we can easily do discussion with we can easily find the distance between a known point to known point, and then analyze that what is this point. You are getting my point? Are you getting my point? Earlier, what happened? What happened? Yeah, what we do, like let's suppose this is our unknown point. I don't know. I don't know. This is the circle, or this is the triangle or a square. Triangle or a square. So how can we do, like let's suppose which one is the nearest? Okay, so let's suppose I decided, like and this is the square. So let's suppose I decide, like k is equals to 2. That means I want to take the two nearest objects. According to that, I will decide here. This is the square or triangle. So we can easily divide. But let's suppose I want to say that I don't have some distance point. I don't have distance point. Okay, and then I want to decide. Like this is, let's suppose how can I describe? Okay, let's suppose we have two points. uh, I want to decide male or female. You are the male or female. I want to decide you are the male or female. I want to decide you are the male or female. And this is the unknown gender. This is the unknown gender. Around with this gender, someone is male and someone is female. I want to know, hey, this gender is male or female. How can you identify? How can you identify? Anyone? Yeah, a little bit like right. But okay, so for nearest neighbors, they calculate some distance, Euclidean distance or Manhattan distance. But here, there is no such kind of distance is there. No distance is there. So, but point is nothing. So in this case, we'll do discussion today. There is one thing is that let's suppose we'll find out, assume that this is called Hamming distance. This is called Hamming distance. So this is says, like if we'll find same as it is, same object, male. So we'll consider like a 0, and if consider male and female, so we consider the distance is 1, 0 and 1, 0 and 1. So in this type, we'll do discussion Hamming distance. This is Hamming distance. So in our previous session, I told you, like I will describe here what is Hamming distance and what is. So the question is, can an argument algorithms will not accept below values? The answer is random tree, but it accept brute KD tree and ball tree. Today we'll see what is KD tree and ball tree. Before that, we can see here, you can refer this docs for, you can see here, the information theory, the Hamming distance between two strings of equal length is the number of position at which corresponding symbols are different. This is, you can also go with this Hamming distance also. So let's complete this one first. K-NN algorithms. So K-NN algorithms, coming to that official site, nearest neighbor. You can see here, once you call here k sklearn dot nearest. In this sklearn dot nearest, we have a k neighbors is there. We have a we have a regression is there. Type here. We can see. Okay. So you can see here. The k neighbors regression is there. K neighbor classifier is there. That means this neighbors is used for classifier, the classification or regressions both. This neighbors, sklearn neighbors is used for, in sklearn neighbors we have a classifier, we have a regressions. Okay, if you want to use directly that statics directly internally, this k neighbors classifier used KD tree, ball tree, okay, brute. But if you want to use direct algorithms, so you can use this one direct also. If you want to know what is KD tree, I think it's not okay. So you can see here KD tree for fast generalizes any kind of problems. We'll see here array lists. So today we'll do discussion here. Coming to that point here, sklearn.neighbors provide functionality for unsupervised and supervised neighbor-based learning models. That means we can see here this sklearn.neighbors, the sklearn.neighbors provide some algorithms for machine learning, which one supervised and unsupervised learning both. So this algorithm will be used applied for both learning. We can see here sklearn.neighbors provide functionalities for unsupervised and supervised neighbor-based learning methods. Unsupervised nearest neighbor is the foundation of many other learning methods, notably manifold learning and spectral clustering. Supervised neighbors-based learning comes in two flavors. Which one? Classification of data, that means discrete level, and regression of data, that means continuous level. Coming to here, the principle behind nearest neighbor method to find predefined number of training sample closest in distance to new points and predict the level from this. That means now I want to discuss this line. Neighbors based methods are known as non-generalizing machine learning methods, since they simply remember all of the training data in a fasting indexing such as ball tree or KD tree. Ball tree or KD tree. Coming to that algorithms, so you can see here in this we have a nearest neighbor classification, we have a nearest neighbor regression here. Okay, we have nearest neighbors regression here. Coming to that nearest algorithms. So this nearest neighbors algorithms internally use brute force, KD tree, and ball tree. Brute force, KD tree, and ball tree. So today we will see what is brute force. What is brute force? Let's suppose you can see here fast computation of nearest neighbor is an active area of research in machine learning. The most navy neighbor search implementation involve the brute force computation of a distance between all pairs of a point of data set, or n is a sample of in d dimension approach scale as a ODN square. So let's suppose I'm saying here I want to find, let's suppose I'm taking here, I have a age here, right? I have a age here, then I have a weight here, I have a age here, then I have a one parameter, one attribute is age, another, and so you can say this is the x1, this is the x1, that means input, this is the x2, and this is another one is hair length, this is the x3, and then I have a output, that means label is defined, y is there, I want to find gender. Here I'm giving three data, one is age, then weight, then here, according to that, I want to find the gender. We have a age, we have a weight, and we have a hair. According to that, I want to find the gender. You are getting my point. So how can you do that? How can you do that, Ashif? Okay, so we can see here we have a x1, we have a x2, we have a x3 is okay, right? The weight and here is weight and here is weight and here. So so machine will be calculated, and according to that, let's suppose age is I'm giving here 30 years, okay, and weight is 57 kg, and hair length is 50 centimeter. So generally, the length, if the length of hair is more, then you can say here this is the female. Same as it is. Let's suppose I'm giving here 6 rows. How many? 6 rows data. That means we have a 6 sample is here, and how many attributes, input attributes is here, how many column is there, how many column is there, right? Tell me how many column is there? Three. How many column is there? Three, right? So you can see here the order of time to compute the actual distance, it will take the order of dn square, order of dn square. That means how many dimension, there is a 3 dimension here, and then how many sample is given, 6 sample is given, so 3 into 6 square. So this is the actual time it will be taking through the compute of the distance. You are getting my point. So what will be the problem, like in brute force? Let's suppose our dimension is more. Let's suppose our dimension is more and sample is more. So you can see here. You can see here. Let's suppose I have a 20 dimension, and sample is given like a 100. So you can see here how computation time will be increased. 10 into 100 square, 10 into 100 square, you can see here how the order is going. Computation time will be increased. You are getting my point. What is the D? D is nothing but a column. What is the N? N is nothing but number of rows or sample. So you can see here, fast computation of nearest neighbors is an active area of research in machine learning. The most Navy neighbors search implementation involve the brute force computation of distance between all pairs of points in the data set. Of n sample means number of rows will be n, and d dimension, d is nothing but attributes. The approach is as will be order of dn square, order of dn square. D means dimension, n means sample. That means d means dimension, n means sample. D for dimension, d is nothing but attribute, n is nothing but sample, rows. So this efficient brute force neighbor search can be very competitive or a small data samples. However, the number of sample n grows, the brute force approach quickly becomes infeasible in classes with scalar neighbors. So brute force neighbor searches are specific using the keywords algorithms is called brute. Internally, you can say here, even though you can say algorithm, so internally algorithms equals to brute you have to pass. So as we know that as per the discussion, this brute force will not applicable for high volumes of data. High volume of data, you can see here how the order of complexity is increasing. Dn square number, if number of sample is increasing, if number of sample is increasing, the computation time will be increasing. So brute force, you can apply the nearest brute force algorithms for calculating the nearest neighbors. So you have to apply this algorithms only or only if you have a small sample of data like a 10 or 15. This will be fine. You are getting my point. Then after, next algorithm internally is KD tree. So what is this KD tree? As we know that tree. So what is the tree? Tree is a data structure that is used in a tree format. We have a root, then node, then root, then node, then root, then node. In this format, tree is working. So let's see what is the KD tree. We can see here, to address the computational inefficiency of brute force approach. That means whatever the drawback of this brute force approach, KD tree will give some improvement. So to address the computational inefficiency of brute force approach, a variety of tree-based data structure has been invented. In general, this structure attempt to reduce required number of distance calculation. Here, our distance calculation, numbers of the distance calculations is increasing. But we can see here the structure attempt to require the number of distance calculation by efficiently encoding aggregate distance information for the sample. The basic idea is that if A is very distant, let me describe here. So here what happened with that, let's suppose this is the point I want to, and this is A, this is B, this is C in tree format. This is A, this is B, and this is C, and in B and C there is another one is D and D, and this is E. This is E here, let's suppose this is D here. So if I see here in tree, we can internally the algorithms will be, without calculating the distance, they can easily predict that their roughly distance. You can see here you can assumption that if the distance between A and D is very far, if the distance between A and D is very far, if you can listen my statement, first listen the statement what I'm trying to say. If the distance between A and D is very far, the distance between A and D is the very far, right? If the distance between A and D is very far, and D and E is very close to each other. So you can see here the distance of A to E is also far. You are getting my point. The statement is first algorithms calculate the distance between A to D, and algorithms calculate the distance between D to E. So as we know that A to D is very far and D to E is very close. So algorithms automatically tell, hey, A to E will be also very far without any calculating distance. You are getting my point. Got it? Hey, I don't know why people are not attending the session. Because this is the important one. That's why I left this concept. I would like to describe this concept after that. Can anyone drop the message that session is very important? Anyone drop the message in group? Why people are not joining? Right. Could you drop this message, please? Okay, do that. Okay. So we can see here the KD tree, the distance between A to D. So we can see here the one step will be eliminated automatically. The distance between A to E will not required to calculate. So how the tree is structured A to B and C, then D and E. First, the algorithm will calculate the distance between A to D. Fine, this is the very far, and D to E is the very close. So the algorithm next step we no need to calculate it. We can directly say like the distance between A to E is very far because D and E is close to each other. So if D is far from A, so E will also far from A. This is the concept say here. You can read here. The basic idea is that if point A is very distant from point B and point B is very close to point C, then we know that point A and C are very distant without having to explicitly calculate their distance. So without calculating explicitly the distance, algorithms will say, hey, this is also far. In this way, the computational cost of nearest neighbor search can be reduced, and now it will become dn 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 log n dn log n. Earlier the complexity was order of dn square. So hey, kindly remember this. In interview sometimes we'll ask what is the complexity of brute force, what is the complexity of KD tree. Complexity means nothing but number of computation. Like complexity means here more time is required to computation the result. Here in KD tree in comparison to brute force, less times will be required to computation of distance. Why? Because n square and n log n, which one is the greater? Let's suppose I'm saying here, I want to know 10. So 10 into 10, what is the values? 100. What is the values? And I want to find it n log n. What will be the value? Ashif, do you know log n? What is the values of log 10? Log n means log 10. What is the values of log 10? What is the values of log 10 base 1? Tell me guys. What is the values? Okay. Log n, my log n. What is the values of log 10? Yeah, you all are from math backgrounds. I don't know why you're not able to answer. Hey man, log 10, the values of log 10 is 1 only. So you can see here, if you multiply with 10 into 1, output will be 10. Output will be 10. 10 into 1, output will be 10. Here you can see here, 10 into 10, output will be 100. So which one is required more time? Tell me. Brute force or KD tree? Brute force or KD tree? Which one is required more time? Yeah, brute force. So 10 log n is 1. Yeah. So 10 log, yeah. So hey, Lakshmi Priya, why you joined very late? Any specific reason? Lakshmi Priya, are you there?
Yeah. Yes, sir.
You
Just
forget to
I'm
join, or why you joined?
sorry, I slept, sir.
Okay, for 3 months you have to. Yeah, this is the journey of 3 to 4 months. Kindly give that. So today I described here. Let me give up one quick recap here. Today I describe like in today I describe here why internally, as you know that in our scalar neighbors, so we have a two type of machine learning majorly. One is supervised, another one is unsupervised. Even though we have another machine learning is also a reinforcement learning, but I will describe this reinforcement later because no one is using reinforcement. So we have a supervised and unsupervised learning. In supervised learning, we have a two type of supervised learning. One is classification and one is regression. So this KNN algorithms is used for whole supervised and unsupervised. If you take that scale on that neighbors, in this neighbors package, we have a KNN classifier, we have a KNN regression unsupervised. Okay, even though once you try with once you write here, let's suppose KNN classifier here, KNN classifier, and if you want to know what is this KNN class, sorry, if you want to know what is this KNN classifier, we'll see. KNN, this is a class, it will be pass here, let's suppose. We can pass here neighbors. You can pass here and you can see here what is. So in K-neighbors classifier, they internally used some algorithms for calculating the distance, as we know that calculating the distance. So we have algorithms is called KD tree, and then brute force, KD tree, and Bolt tree. So these algorithms I'm describing. Another one I describe here, how to calculate. Let's suppose we don't have a distance. We have a only object, and let's suppose this is the male and this is the female. Okay, and there is another gender, I don't know what is the gender of this guy. So how can you calculate? So for this we have apart from Euclidean distance or Manhattan distance, we have another distance is called Hamming distance. We have another distance is called Hamming distance. So we'll do discussion on this point. But as of now, I describe here what is what is I describe from here. You can go. I describe from here what is nearest neighbor. So for nearest neighbor, the algorithms is used. You can see here in nearest neighbor, algorithms is used. So this KNN algorithms will be used only supervised or unsupervised. This KNN nearest neighbors will used only for supervised or unsupervised. Anyone? Lakshmi Priya. This KNN algorithm, K nearest neighbors used for supervised or unsupervised?
Supervised, sir.
Why? Why not unsupervised?
I'm saying supervised.
Why not unsupervised? This nearest, yes. I never told told this statement. This nearest neighbors will be used for whole machine learning, like supervised or unsupervised learning both.
Okay.
In supervised learning, we have a nearest neighbor classification. As of now, I only show like a K neighbors classifier. In next in our upcoming session, we'll see K neighbor regression. Unsupervised, we'll see. Don't worry. Today I'm describing here. You can see here, this is the KNN, this is the linear regression, this is the race, this is the extra tree, this is the true phases. So today I'm describing here this nearest neighbors algorithms. Like internally, this KNN algorithms use some algorithms to calculate the distance. So that distance, as of now, algorithms, instead of algorithms, you can see here, by default, we are using auto means automatically it fixes, hey, you have to use brute force, you have to use KDT, you have to use Bolt tree. So what is brute force? Brute force is, what is brute force? You can see here, for fast computation of nearest neighbors is an active area of research machine learning. The most neighbor search implementation involves brute force computations or of distance between all pairs of points to the data set. So let's suppose I'm giving here, I have a age, I have a weight, and I have a here, okay, and I want to find the gender. So 3 level is given. X1 is given, X2 is given, and X3 is given. X1, X2, X3 is given, and here Y is given. X1 is given, X2 is given, X3 is given, and Y is given. Age is given, weight is given, here is some sample data. Age is 40, then weight is 60 kg, then 50 centimeter. Then age is 30, then weight is 78, and then hair length is 10 centimeter. So this kind, so on. I'm giving here 6 sample data. So how to calculate in brute force? How to calculate the computational complexity. That means time to compute all the distance of that sample. So the formula is the given algorithms give that it work on dn square. What is the meaning of d and what is the meaning of n? D means dimension and n means sample. So d dimension is nothing but our column. So what dimension is given here? There is 3 column is given. So you can say d is 3. What is n? N is nothing but sample. So what is the sample here? We have a 3 sample is given, means 3 rows is given or 6 rows is given. So you can say this is the 6 rows. So you can see here 3 into 6 square, it will take the computational time. 3 into 6 square here. So what is the disadvantage of this brute force? The disadvantage of brute force is, let's suppose our sample data is increasing day by day. Okay, so the values is increasing in exponential in a square, you know that, because the order says like a dn square. So let's suppose nowadays our data is 10, sample data is 10. Let's suppose, but in our future the sample data increase 10 to 100, 10 to 100. Yeah, this is not a time actual. Time is in unit. That unit should be anyone. You are getting my point. The time is, algorithms how to calculate the complexity. What is the order? What is the Vigo? This is the Vigo order. Vigo O. This is called big O order of for complex for you know that. I have to describe here. There is 3 things. We have a best case, okay. We have a average case, okay, and we have a worst case. Okay, we have a average case. We have a average case, best case. Okay, so for this we have a big O1. We have a omega, big omega. We have a omega. Okay, and then theta. There is 3 things for calculating our complexity. Let's suppose I given here one problem. I'm giving here one problem. Y is equals to and let's suppose I am giving here like a sum, solve sum 2 plus 3. You have to calculate the result 2 plus 3. What will be the output? Or let's suppose you are searching something. Let's suppose you are searching something, and here is 1, here is 4, here is 5, here is 6, okay, and here is 10. All right. So let's suppose you are starting searching from here 1, 4, 5, 6, 10. 1, 4, 5, 6, 10. How many items is there? 1, 2, 3, 4, 5 item is there. We have a 5 item is there, and you are searching. So what is the best condition is that? What is the best condition is that? What will be the best condition? Let's suppose you are starting the searching, and I want to know that you have to search the number 10. So Y control will be go first. It search here. Hey, 1 enter. No, this is not our number. This is also not our number. This is not our number. This is not our number. This is our number. Wow. So this is the worst condition. The time taken by, let's suppose, for visiting the node here, time will take in 1 unit. The unit will be anything. Time is taking here 2 unit. So 1 unit, 1 unit, 1 unit, 3 unit, then 4 unit, then 5 unit. Total time it takes for reaching this element is 5 units. How much? 5 units. You are getting my point. Total time it takes for reaching here. This is the 5 unit. But so now can the time will take among more than 5 units in any worst condition? It will take or not? Ashif, are you there? Are you there? Okay. So in very worst condition, time will not take more than 5 units, because as we know that 1 unit takes 1 unit time. One element takes 1 unit time. We have only 5 elements. So time will be take in worst condition, worst to worst condition, time will take 5 minutes. Sometimes in average condition, average condition, let's suppose our 10 is here, 10 is here, and instead of last element, 10 is here, you know. So it will take only 3 units time. What is the best condition? Let's suppose instead of 10, where, hey, this is our best condition. Sometimes what happened? Sometimes what happened, like you know that bus frequency. Let's suppose this is the time right now. The time is 6:30 a.m. The first bus will be starting. Okay, and then another bus will be start here 6:45 a.m. Sometimes what happened, once you reach your platform, and then suddenly your train is moving like. So at the first attempt, what is the best case? First attempt, you pick your respective distance. But sometimes it will take some times in worst condition. There should be worst condition. Hey, somehow you give one deadline. Hey, sir, I will deposit the money by 27. This is my worst condition. Anyhow, I will deposit the money by 27. And what is the best condition? 25/6 morning. So generally in our life also, there's, if you want to be happy, so generally in our life you have to take approach only worst condition. Don't think like a best condition. Somehow this best condition will be failed, so you will be get a problematic. Let's suppose you are giving some commitment to someone. If you are giving some commitment to someone, hey, I can give 100 rupees. So first you have to calculate your all worst condition. Hey, you have firstly you have to calculate, is there a calculate all the worst condition, and then you have to give their worst condition date. And you are getting my point. If will, yeah, best and worst condition clear. All right. Average one is like a average one is same, like a middle of that time. So same as it is, most of this O is this O is denoted for this big O is denoted for worst condition. Then we have a then we have a sigma theta and delta. So these are the denoted for average and best condition. But here in our algorithm, we always take, most of the time we always take our worst condition. So O is meaning of worst condition. Like anyhow, it will take this time dn square. You are getting my point. But if you are talking about the KD tree, what is the meaning of KD tree? KD tree works as a tree. This is our tree. KD tree is work as a tree. Let's suppose I say here. So we can see here in tree, we can see and assume that which one is the far from here. Let's suppose I'm seeing here. This is our root A, and this is D, and this is C. Which one is the nearest to C? Nearest to A, C and D. So anyone can see, look and see. Hey, C is the nearest to A, and D is far from A. So somehow let's suppose if condition says like if D is far from A, so and D is nearest to E. There is two conditions. D is far from A and E is nearest to D. You can see here D is far from A and E is nearest to D. So you can say E is also far from A. You can see here, if A is very far from D, so D is very far from A, and D is nearest to E. This is the very far from far, and this is the nearest. D is nearest to E. So you can see here, A to E is also distance is very far. You are getting my point. Anyone can say. You are getting my point. Hey, Lakshmipriya, it's clear. So this is all about KD tree. KD tree means the address of computational inefficiency of the brute force approach. Variety of test-based data structure has been invented. This structure attempt to reduce required number of distance calculation by efficiently calculation aggregate distance information. You can say here the basic idea is that if point A is very distant from point B and point B is very close to C, then we know that point A and C is very distant without having to explicitly calculate their distance. So you can see here in comparison to first one is given complexity is dn square, second one is given the complexity is dn log n. So which one is the best in comparison to brute force and KD tree? Which one is the best? KD tree is the best, because let's suppose our sample is 10 here, so and dimension is 3. So here 3 into 10 square, it will be become 300. Calculation computation times, it will be 300. Here dn n log, so the d means 3, n means 10, and log n. So what is the meaning of log n? Log 10. What is the output of log 10? Output of log 10 is 1. So you can see here, this is the 30. So which one is the better? 300 is better or 30 is better? Tell me. Lakshmipriya, are you getting my point? I revised you for only you. Lakshmipriya, are you getting? Got it or not? Tell me. Got it or not? Tell me first. Any doubts? Okay. There should. Okay. Next one is coming to data. Coming to data. Next approach. Got it. Thank you. Coming to next approach. What is the next approach is? Next one is ball tree. So KD tree is also some also some drawback. What was the drawback for brute? If the number of sample, that means n is more, the number of sample, that means n is more, we should not use brute, because computational time will be unnecessary become high in case of if you are increasing, because you are using n square. If we have a 10 sample, so you have to visit 100 times. If you have 100 samples, so you have a visit 10,000 times. So this is how, because the number of computational is increases in a square exponential. Same as it is, KD tree has also some drawback. An early approach to taking advantage of this aggregate information was the KD tree data structure, sort of k-dimensional tree. KD tree means k-dimensional tree, which generalized two-dimensional quad tree and three-dimensional octet tree to an arbitrary number of dimensions. KD tree is a binary tree structure which is recursively partitioned as a parameter space along with data access. You can see here. So let's suppose it will be also become inefficient. We should use this. So let's suppose the d is less than less than 20, up to that it is fine. Okay, the credit code is very fast for low dimension. What is the standard it defined? D should, the standard it is defined, a standard it is defined, D is less than 20. D is less than 20.
Hello, sir.
Am I audible right now? Am I audible? Okay. So we can see here credit tree is also some drawback. Okay. So if your dimension is very large, so we should not use credit tree. If your dimension is respectively low, then we have to use credit tree. If your sample is low, then you have to use only brute. So next one is, what is next one? Next one algorithm is, you can see ball tree. Next one is, you can see ball tree. So to address the inefficiency of credit tree, the address of inefficiency there. So first is the address of inefficiency of brute credit tree is defined. The address to address the inefficiency of credit tree, ball tree is defined. Ball tree is defined. So you can see here, ball tree and data structure was developed where credit tree partition data along Cartesian X and ball tree partition data is nesting hypersphere. That means internally the credit tree using partitioning of data along with Cartesian axis, but poultry partitioning the data in series of nesting hypersphere. That means internal mechanism is very efficient of ball tree in comparison to credit tree for partitioning the data. This make tree construction more costly than that of credit tree, but result in data structure which can be very efficient or highly structured data. So ball tree recursively divide the data into the node. So you can go on through with the ball tree, okay, and tomorrow session we'll do discussion. So finally, which one is the best, and we'll do discussion what is the leaf size, and we'll do some analysis. Then after we'll come back of which one, grid search CP. You are getting my point. Today your work is you have to go through with the what is the nearest neighbors, and you have to go through with what is a credit tree, ball tree, and brute. Thank you so much. We'll meet tomorrow.